Okay, looking at the x-intercepts of functions. Now, I noticed that for the most part, they get a little bit harder towards the end of the set of problems, but for the most part, they're fairly easy to factor. A and B, I can see the factors by looking at them. C and D are fairly easy to factor. So, in factored form, for A, we have 3 zeros, and they all have a multiplicity of 1 because each factor only appears once with no exponents. So we have x equals -4. Don't forget to change the sign, -1 and 6. There's our 3 zeros. And on B, we also have 3 zeros, but a couple of them have multiplicity, and that'll come up later. So our first zero of 0, the one in 3x squared, has a multiplicity of 2 because it has an exponent of 2. So, but we still get, to answer this question, we get x equals 0 and -2 and +1. For the next two problems, I'm going to look at my monomial factors first, and I'm going to factor out an x. That's the highest degree that's in each term. So I get x squared minus x minus 6, which is easy to factor. Two numbers that multiply to give 6 and combine, -6 and combine to give a -1. So we get x minus 3, x plus 2, and that gives us zeros of 0, 3, and -2. Moving on to the next one, I can factor out an x squared. That's my lowest degree variable, and it looks like I can also factor out a 2. Again, uncovering a quadratic that's easy to factor. And zeros of 0 with a multiplicity of 2, 5, and +2. A couple more that are not easy to factor. In fact, I'm gonna stop and set these up. I can try factoring by grouping on A, and when I do that, it won't really work because I can take an x squared out of the first terms, but when I try to factor something out of the last two terms, nothing will factor, and if I just use a 1, then I don't get the same binomial. So that won't factor by grouping. That one I'm probably going to have to put in the calculator. However, on B, I can factor this like a quadratic because this is twice of that. So I can factor this like x squared plus 51x plus 50. Now factors of 50 that combine to give me 51 are 50 and 1. So I can actually factor this as x to the third plus 50 times x to the third plus 1. Now I got to think about how those will factor. Okay, so I put in my calculator part A, and I also put in part B, but the only graph you can see right now is part A, so let's take a look at that. I have zoom 6, and it's clear that we have zeros at -5, -2, and +1. We probably could have factored that, but not easily, and I don't see the point. Okay, so I'm going to go to the second equation. So just, if you press enter on the equal sign, it'll turn that equation off and on. And let's see what we get here. Okay, so I see 2 zeros, and one looks like it's a fraction. So I see a 0 at -1, and for a even degree, actually that's not too bad. I see a 0 at -1 and another one at not sure where. And I believe on the quizzes these are all obvious. What probably happens is this probably gets factored as the sum of 2 cubes in order to get that other 0 to show up. So I've got a 0 at -1, and I'm just going to estimate these. No, I'm not going to estimate them. I'm going to calculate them. So second trace, let's give me a 0 between, it looks like 1, 2, 3, 4, -4 and -3. We get -3.7. And again, on the XYZ, it'll be a little bit clearer. Not the best example. All right, let's tackle this one. State the degree of the polynomial, find all roots, real and imaginary, and state the multiplicity. So this is asking us to factor. And right away, I can factor out x to the 4th. And when I do that, I see the difference in two squares. And now they want us to talk about multiplicity, which just has to do with the exponents on your factors, or however many times they appear. So I have a 0 at 0 with a multiplicity of 4. And then I have zeros at -1 and +1, multiplicity of 1. All right, that'll do it for this video.